How many of you were in my previous presentation, the business version? Okay, few of you. So I will use about 2 slides to talk about what is converged infrastructure, what does it mean, and then we'll go how this thing works, and then I'll do some demo stuff, building data stores, copying, cloning virtual machine, moving them between data centers in seconds, and all the cool stuff. So let's start. So those of you who saw my last presentation, we went through how most of the virtualized data centers are built today. Where you have your physical servers, you have your storage switch. It may be IP switch or a block storage SAN switch. You have your high available storage systems. We heard a nice presentation just now about the NetApp systems. You might have SSD, like full SSD for that really high performance, low latency stuff. You might need backup appliances, one acceleration, one optimization boxes, cloud-based storage caching, etc. So basically, the reason why you need all these different kinds of boxes is that because in your data centers, when you have more and more data, you start to have what we call an I/O problem. I/O, like IOPSes. Problem with the I/O, meaning that let's say that you have a virtual machine running on your servers. What it does daily, you do backups to it, you might do remote replication, you might do cloning and moving. So a lot of I/O happening with that one virtual machine on that whole stack. So that's why industry has built a lot of different point solutions to solve those problems. But this has generated a situation where your administrators are sitting with huge amount of different user interfaces. You have a user interface, your storage, you have user interface, your servers, your backup, etc. A lot of different kinds of things to maintenance in a situation where you have a lot of boxes, a lot of screens, a lot of IOPSes when the data is going through between all these systems, and a lot of refresh cycles. Let's say that you have to upgrade your switches. You have to play with all the compatibility matrices. Does this model of the switch work with these HBA cards and with this storage, etc.? You know all that stuff in the data center. So this legacy way of building data centers where you buy servers from vendor A, storage from vendor B, maybe backup from vendor C, backup software from somewhere else, it's starting to be a real problem how to manage all this. So the industry has came up with several different kinds of solution, and as I told in the earlier presentation, one of the kind of hype words or one of the movements that have happened in the last 4 or 5 years is the converged infrastructure, converged architectures. So if we look at the legacy stack, where you build your own data center, where you gather all these blocks from all different areas, the problem was here that you have to do a lot of integration. So the first generation of converged architectures or integrated systems was a great idea. Let's take the servers, let's take the switches, and let's take the storage and make these integrated systems like the vPlex and the FlexPod and those systems that you can buy from the companies that really makes it easier and faster to implement a data center. You get single point of support and all the cool stuff. But in many cases, what was left out are a lot of functionalities that you need to run an enterprise data center. The kind of first real converged architecture is the way that Facebook, Amazon, Google, and those kind of cloud companies are building their data centers. They don't have centralized storage systems. They are using basic x86 systems and using the internal storage to build a virtualized storage. An awesome idea again. You just got rid of a lot of complexity. You use basic x86 building blocks. If you need more capacity, you just add those blocks to your environment. But again, a lot of the enterprise functionalities, especially in these systems, were lacking, like how to do remote backups, how to do backups and recoveries in general. So what SimpliVity Omnicube is doing is taking all the functionalities of the whole stack and bringing it to this x86-based, kind of a cloud-based thinking, but bringing onto this the enterprise capabilities with data protection, data efficiency. As I promised in the previous presentation, now I'm going to actually explain what does that mean. Performance and global unified management. Managing all the functionalities of the legacy stack with a vCenter plugin. So the same vCenter that you are using to operate your VMware anyway, let's use that to do all the enterprise capabilities that you need. So that was the short version of the half an hour presentation earlier. So let's go into the Omnicube, the actual building block, what we use to build a VMware or virtualized data center today. As I said, it is a basic x86 type of server. We have two flavors for hardware. We have an OEM agreement with Dell. So the Omnicube actually is based on the R720XD Dell server, or we have just announced in the VM world the Omni stack for Cisco UCS. So if you have a UCS environment, it is really easy to just add C220 Cisco servers with the Omni stack installed and get all the functionalities that I'm going to tell you about and demo in just a few moments. So inside this basic x86 based building block, we have just the normal stuff that you would have in a server. You have your CPUs, you have your memory, you have SSDs, and you have the spinning disks. On top of that, we put the hypervisor in the factory, and in this case, it's a ESXi. And between the ESXi, the hypervisor, and the hardware is what we call the SimpliVity Data Virtualization Platform. So what happens inside here? In the heart of this platform, we have what we call an Omnicube Accelerator. As I told in the previous presentation, they spent, the engineering team spent 3.5 years in stealth mode to build this technology. So what we have here is a custom ASICs built for inline deduplication, compression, and data optimization. I will explain what that means in just a few moments. Why do we have that? You could do deduplication using the x86 CPUs. You could do that, but then that would be about the only thing that your ESX host would be doing, deduplicating. And probably it's something that you need those CPUs for running your production environment. So this is actually why the competition who are doing deduplication with the x86 CPUs, with the built-in CPUs, are doing the deduplication as a post-process. Just to clarify what post-process means. Post-process means that if you have a 100 gigabyte virtual machine, let's say that you deploy a 100 gigabyte virtual machine, if you do a post-process deduplication, you write that 100 gigabyte to the disk, then in a convenient time, like 6 hours later, you read it to your x86 CPUs, you do the deduplication, and then write the deduplicated blocks to the disk. And you just generated almost 3 times the I/O of a normal kind of just writing to the disk. So post-process deduplication sucks. It generates a lot of I/O, it generates a lot of load to your production systems, and it is really, really difficult to use because you have to think about, okay, maybe tonight at 8 o'clock I have a low load, I can do some deduplication stuff. So what we do with the Omnicube Accelerator, it's an extremely powerful card built to do deduplication and compression inline, almost wire speed. And it is protected for power loss, so if you run out of electricity, it will write all the blocks that are in there to the flash, etc. And also, you always deploy 2 Omnicubes when you want high availability. If one card dies in there, all the virtual machines running on that host actually can still run, read and write all the data through the other node. So it is redundant. If somebody wants to talk about I/O path and stuff like that, with 30 minutes, we are not going there today. We can do that tonight. I will be here until 6, I think. So what happens on top of that card? There's the OmniStack software. So keep in mind that here is the heavy lifter, the powerful card underneath doing this stuff. And on top of that, we have the OmniStack, and we separate that into kind of 2 layers. We have the presentation layer that looks to ESX as the storage. And then we have the data management layer where we do all the cool stuff. So if I have a virtual machine here, I have my presentation layer and the VMDK files are living in the presentation layer. Oh, sorry. So what happens if I have a new write? So this first virtual machine does a write. It gets registered to the presentation layer. Of course, it's a change to the VMDK file. But what we do in the data management layer is that we check that do we have this 8K block on the physical disk? And if we do not, come on. If we do not, we compress it and write it to the disk. We get a new write from the other virtual machine. Again, it gets registered to the VMDK file, but in the data management layer, we check that do we have it physically? No, we have to compress it and push it to the disk. Third write, a unique new write to the whole cluster. We don't have it, we compress it to the write and do the physical write. Now let's say that this virtual machine manages to generate a new block, totally new block for this machine. It writes to the VMDK file, but in the data management layer, we check that, oh, we have that block already. I just point in the metadata that this block also belongs to this and this, and I don't do a physical I/O, which is, stay with me, and why that is extremely cool. So next time I have a duplicate block, again, I just mark it to the metadata. I don't do a physical write to the disk. Third time, and when the system is running, we actually, all the virtual machines are writing full speed to the data virtualization layer, running on top of that card, but we only do physical writes, physical I/O, when any of those machines in this cluster has managed to generate an 8K block that was not physically available here before. In the previous presentation, we heard about using SSDs for caching and stuff like that. We do that. So all the hot data gets cached into the SSD and also to the part of the memory, so we get extremely fast reads also. There is a good white paper in our stand about the performance and how we are linearly scalable, getting huge amounts of IOPSs out of these systems. This is what happens in the data virtualization platform. So the virtual machine actually is metadata pointing to the physical blocks in the physical disks. And a single block actually belongs to several different virtual machines and, of course, inside that VMDK file to several different areas of that file. So what does this actually mean on top of the fact that, of course, we use a huge amount of less capacity? because we deduplicate everything in line. Oh shit, what was that? And then we restart our PowerPoint. Sorry about that. Thank you, Bill Gates. Okay, it opened all my presentations. Nicely done. Okay, here we go. Okay, back in business. So here I have the same picture, but now I have a 3-node cluster. So all these deduplicated blocks are on several of these nodes. So if you lose one, you still have all your data and the virtual machines are running happily. So as I said in the previous slide, the virtual machine here is actually metadata pointing to the physical blocks. Let's say that I want to do a 2 data center environment. I just add another cluster to another VMware data center and then add those systems to the cluster, to the federation, sorry. So what happens if I want to do a backup of this virtual machine? I don't have to think about shares or LANs or any of that complicated storage stuff. I just make a backup policy saying that take a local backup every 10 seconds, because every 10 minutes. I can do every 10 minutes because I am not doing real I/O. I am not bringing load to the system. What I did was that I copied the metadata. I have a full backup, local backup. Okay, some of you guys might say, or ladies, might say that, okay, the backup is in the same boxes as the production. Yes, that's why we usually do a 2 data center solution. Where I want to do a remote backup, same thing. I just copy the metadata there, check which of the blocks I have there already, and if I don't have some of the blocks, I only move those blocks to the other side to get the full backup. So I usually use an analogy of Legos here, just to make this really clear. Let's say that this virtual machine is a Lego racing car. Everybody knows what Legos are. Yeah. And most of us have played with them. Some of us do still. I'm a geek. So let's say that this is a Lego racing car. The metadata here is the instruction book, how to build that racing car. And then I have a bucket of Legos in my storage, like individual Legos. So if I want to do a fast remote backup, I just send the instruction book there and check what Legos I have in this bucket and use those. And only if I'm missing some special steering wheel Lego, that's the only Lego I have to send here to have a full backup on the other side. I had in my previous presentation again, I had a customer reference, Petrobras, which is one of the top 5 oil companies in the world. They have a 2-node, 2 Omnicube cluster on their oil ships. And they are backing full virtual machine backups over a 2 megabyte satellite link to the Texas data center. Full backups over a 2 megabyte line. And if I want to do a fast recovery there, I just register this virtual machine to the presentation layer. It comes up as a VMDK file to the vCenter, and I have a live virtual machine there. Globally federated architecture. In this, I have a 2 data center environment, and with this I can build, let's say I want to have a backup policy that backup this virtual machine every hour locally and keep it for 12 hours. Then I make another rule that the same virtual machine, I want to have a daily backup to New York. But if I get more data centers, I just add them to the federation and I can do backup policies saying like do local backups here daily, weekly there, monthly there, then to Amazon Cloud every 6 months, and to Tokyo like every 2 weeks. So I will show in the demo how to play with backup policies. It's really, really easy. You just take the backup policy, you put it to the data store or an individual virtual machine. So I'm not tied to share, backing up shares or LANs or all that storage stuff. I am protecting virtual machines, individual or groups. This is the user interface. It's a SimpliVity tab in the vCenter. And depending on which level, you will see this in the demo, if I'm on the top level, the federation level, I have a different kind of view, depending on what I want to do. On the data center level, I have a different kind of view, different kind of functionalities, and of course on the virtual machine level, I have all the backups where I want to recover, etc. You will see all these in the live demo. So to start, the other nice thing is that you don't have to start big. You can do a 2-node cluster, what we call a 2 plus 0. But then you only have local backups. If you lose one of them, you have VMware HA, all the virtual machines are running on the other one, but you don't have remote backups. Of course, this is an ESX. If you want to use your legacy backup software, by all means do. And then you could do some export backups to, with Veeam or something like that. But you can do a 2 plus 1 where you do local backups and then remote backups. Or, of course, you can scale to 4 plus 4, etc., etc. So this is the kind of building block idea. You can start small, grow to a huge thing, huge environment, very, very large, of hundreds or thousands of virtual machines using the same building block. With one node, you get the functionality. With 2 nodes, you get the high available storage plus double CPUs and memory. And then you just add to the same cluster more nodes when you need more storage, more CPUs or more memory. We also scale in, so if you want to remove this or if you want to upgrade this to a next generation of Omnicube, you just remove that one from the federation, put a new one there, and then one by one change those Omnicubes while the virtual machines are running. But also, many of you already have VMware. So between the Omnicubes, you have a 10 gig storage and federation network. And what we can do is we can take that network and stretch it to your existing servers. So let's say that these are servers running on, like UCS servers running on top of Cisco, on top of NetApp or EMC or HP storage. What you can do is a really, really easy migration. You just stretch the Omnicube data stores here, you do a storage vMotion and then a vMotion live for those virtual machines. Or you can run these, get rid of the old storage here completely, and use these as compute heads. The virtual machines are running from the internal storage of those systems. So you can leverage your existing servers until they get older and then just vMotion the virtual machines on top of that. Really, really easy. And if somebody says that, okay, what is this SimpliVity company if they get this hardware lock onto us? How locked is a VMware virtual machine? If you want to get rid of the Omnicubes, you just vMotion back. Easy stuff. This is the current family, CN 2000, 3000, and 5000. The storage is always the same on this kind of direction. So CN 2000, it's a 1-socket, 8-core system, and a few different memory configuration. This is the most popular one, CN 3000, 2 sockets, 8 or 12 cores, memory. Again, this is for the deduplicated blocks, so you can get a lot of data in there, like logical data. And this is the most powerful one with the fastest cores and a little bit faster storage subsystem. But these are the systems that are based the Omnicubes based on the OEM agreement with Dell. The Cisco UCS will be between CN1000 and 5000, the model, the C240. Yeah, thank you. So the idea is to make it really, really simple. Get rid of the legacy stack or integrate those servers as compute nodes. Get rid of all the different management user interface. Have one hyper-converged architecture for your virtualized environment. Have the data virtualization platform deduplicate, compress, and optimize all the data on ingest, meaning that the virtual machine actually is metadata pointing to those Legos in the bucket, and that gives you the mobility of the virtual machines. It is really, really easy to move that metadata to another data center and use the Legos on that bucket, and also the backups because you are working with the metadata, not the actual physical blocks anymore. Makes everything faster, and you will see that in the demo. Can somebody say how much time do I have? 5 minutes. Oh, damn. Yeah, it's simple, but there are cool stuff in here. I would like to show you all kinds of nice stuff. Okay, here is my vCenter. As you can see, let's go to the federation level first, to the top level where I can see my data center. And as you can see, I have my SimpliVity tab here. In this environment, I have two data centers, the Boston and the San Jose. I have, and those are represented here in this graphical way. Plus, I have the Amazon integration feature active in my demo also. Here on the right side, I have the backup policies. And I have here several ones, but I'll show you how to build a kind of generic backup policy. Just a second. Let's hope that my network stays on. Let's give this a name, test. And you will see soon that is our head engineer, Warren, is doing demo at the same time in the US. So I don't want to break anything. He will hit me in the face. So tread easy here. So I made the backup policy here, and inside this policy I can make up to 16 rules. And these rules are really simple, saying that I want to back up every hour and keep it for 10 hours. And keep it those backups I keep locally. And I can do application consistent, so I can go to the Exchange and SQL to tell that go to the backup mode. But in this demo I will not do that because of the time. So that was my first rule. Back up every hour for 10 hours. And then I'll make a next rule saying that do a daily backup and keep that for 30 days. And that you can do application consistent. And keep it to local. Then I could do fourth rule, take in daily backup and keep it in the remote site, in the San Jose site. So I had backups in all my data centers then. So that is the easy way of building the backup policies. It's really, really simple. So now I have a backup policy here called test. I can go to the data store level. Let's go to the data center level here. Here I can see my Boston cluster, and I'll show what you have to know about storage. Let's say that you want to build a 500 terabyte data store. With the legacy stack, you had to go to the probably to the storage guys, or you might have a nice storage plugin. But here you don't have to let's give it a name. Have to think about any LANs or shares or stuff like that. You just give it a name. Choose a backup policy for that one. I could choose the one that I made, but I'll choose the bronze daily now. And give it size, some ridiculous amount. Or let's make a petabyte data store, just for the hell of it. So here you can see that the data store starts to build. This will take about 45 seconds. So I will take a few moments of your coffee break, sorry, because there's still cool stuff coming. That can happen there. That will take about 20 seconds. But while that is doing, let's do a clone of a 5 terabyte virtual machine. I have a 5 terabyte virtual machine, a huge one. I'll do a full clone. Last time I asked any VMware admins here. Are there VMware admins in the room? Anyone? Well, does anybody know? Yeah, 1, 2. How long does a normal clone take? 5 terabytes. Okay, 500 gigabytes. Okay, 30 minutes. Let's make a 5 terabyte clone here. It started, it's in progress. We have started it now. When it hits 33%, it's actually done. And now it just gets registered here. You will see my 5 terabyte clone here. Was that fast? Would that make your life easier when you're cloning machines? Probably. It helps me. Let's go back to the data store that I did. And let's say I made a mistake. It wasn't supposed to be a petabyte data store. Somebody said that it make me a 10 terabyte, and I made a petabyte. I could go and online resize it. Let's make it 10. So I can go smaller also. Really easy. And in just a few moments, resize completed. You will see it gets resized here. Let's take my clone. Now you can see 10 terabytes. Let's take my clone and move this from one data center to another one, to Boston to San Jose. Let's make a move. And the virtual machine, you will see that it will start moving. What is happening in the background, the metadata gets sent from Boston to San Jose, and then we will check that what Legos I have in San Jose, and then I have the system moved. So it will map itself to those blocks. So this will happen in about 30 seconds. 5 terabyte virtual machine between the sites. This is why Petrobras is backing up machines via satellite. Let's do a recovery. Now it's moved. It's here. You can see my virtual machine just came to the other data center. Let's make a recovery, and let's make a cool recovery. I'll take this one that has backed up, oh no, it was that one, sorry. That has backed up to Amazon. So I have a daily backup going to Amazon Cloud, Amazon East. And this is a 72 gigabyte virtual machine. I'll do a full recovery of this virtual machine, sorry. Recover it to the Boston data center. And you will see that the recovery will start in just a few seconds. It's 1, 2, 3, done. So I have that virtual machine here. And just for the fun of it, let's start it so you believe it's actually a virtual machine. One thing that I need to do is I'll disable or go to the network card and tell that don't start up because it will come with the same IP as the owner of this backup. So I will take this one away. And then I'll go, now I remove the backup, the network, and then I power this on. And let's go to the console. Is it powering? Power on, yeah. Ta-da! So I recovered a 70 gigabyte virtual machine from Amazon, started it up in less than 1 minute. This is cool stuff. And the last recovery, let's show that size doesn't matter. Sorry. So I can recover this 5 terabyte virtual machine from San Jose to Boston between the data center, and it is as fast. So I'll recover 5 terabytes between 2 data centers and clusters. I started the recovery, in progress, done. So this is what we mean that we virtualize the data. We deduplicate, compress, and optimize the data. So virtual machine is actually metadata pointing to the pool of deduplicated blocks. And if I want to move, copy, clone, backup, recovery, virtual machine, I just move the metadata and check which blocks I have available there. Some of you might think that, what if it is an empty Omnicube and I recover it there? Of course, the metadata goes there and checks that, oh damn, no blocks here. Then I have to move a lot of blocks. But what I can do is I can trick the system by, let's say I have an empty box, empty Omnicube. I install a 2008 server and 2012 server and maybe a Linux server, just blank operating systems. So I get Legos there already, and then I recover my production system and it goes there. And, oh, there's a lot of stuff that I can already use. So we can trick the systems by doing stuff like that. So as a last slide reminder, this is what we do. Get rid of the legacy storage server stuff and everything. Start to build hyper-converged architecture. Virtualize your data and have one single place to manage the whole stack. And we have an awesome partner here who can help you to build this. Okay. I don't know if I probably went over my time a bit. So if you have any questions, and you probably do I have a minute for questions?
Yeah, of course.
Okay, any questions?
Yes. You say that your system calculates metadata for every data block. Yes? So I think it's some kind of hash.
It is, yes.
Is it any probability that we have two blocks, different data, but the hash will be the same?
I love that question. I worked 8 years at TMC with Avamar and data domain. This is what is called a possibility of a hash collision. What we use is an SHA 160 hash algorithm, which is pretty long. It's not enormous, but it is huge. And the possibility of hash collision is like 1 to about this long number. So it's small. It is a possibility. On top of that, we are not doing only hash. We are doing something that is patented, so I can't tell you. There is a possibility of hash collisioning, but it is probably smaller than one of those servers catching fire. So it is extremely small. But we can, I have some numbers that I don't remember by heart on my laptop, so you can come to our little booth there and we can take a look at those. Any other questions?
Can you add external storage?
Sorry?
Can you add external storage for your box?
Yes and no. What I can, well, of course, for the virtual machines, why would I? I just, one of those boxes has 20 terabytes of storage for deduplicated blocks. But if there is a virtual machine, let's say that I have a virtual machine that is doing something for big data, like petabytes of data, then what I would do is to get a big data storage box and just show it as an NFS there. But I cannot, Omnicubes cannot use NetApp or EMC storage because it's external. It's just, we just wanted to get rid of those. That sucks. We get better performance and better capacity with the Omnicubes in most cases.
On the way to add more SimpliVity boxes.
Yes. So when if you run out of disk from that 20 terabytes, you put another Omnicube, and if you run, you just put another Omnicube. So you get more of everything, and we have tools to help you calculate total cost of ownership, like where we compare to the legacy stack. And especially on the OPEX side, we go like way cheaper. But on the long run, this is the way to build those. There was a question.
Licensing, we need to buy separate number of licenses or is it?
This is an ESX host for licensing. The licenses do not come with this. It's just an ESX host, and you use your existing licensing agreement with whatever you have been using. But it is the 3000 is a 2-socket machine. The 2000 is a 1-socket, like any other ESX host. Any other questions?
How about Microsoft virtualization platform?
Coming. Not this year, probably next year. And KVM also. Okay, so if you get any other questions, I will be here until 6, then they pack us to a bus and we go somewhere else. I don't know. So please come to me and ask questions. We have good white papers there, etc.